So, good morning, colleagues. Good morning, ladies and gentlemen. So, my name is Vidyasagar. So, today I'll take you all through the latest technology innovation of Siemens, the latest CBTC. So, we all know that we are having quite a few technologies in the country. So, distance to go is already proven in the country. Quite a few lines are working across the major metro networks. Currently, the CBTC is going on the communication-based train control. So, we all know that we are having 4 different levels, the GOA 1, 2, 3, 4. The 4 being the highest, which is the uninterrupted train operation, so-called driverless. And the GOA 2 is the semi-automatic train operation, which is based on the ATO. Yeah? So currently, all the major metro networks are going with either GOA 2 or GOA 4 right now. So what it means is actually GOA 4 is it's something which we are going to ensure the train safety completely. All the train operations will go absolutely with the utmost safety. And it will do this by positioning the train accurately. And also it will have a continuous communications between the wayside and the train. So this is the simple basic function. I would just like to take to the next one. So this is the rough architecture. I would just maybe highlight it, where we are having the wayside in which you will be having the interlocking, which we call heart of the signaling system, which will take care of the entire train operations safely. Yeah? And besides this, to ensure the train availability or train occupancy on the track, we do have the train detection in the form of the axle counters, the digital axle counters, the multi-section digital axle counters. And besides this, we are having the point machine signals. On the onboard, we are having the ATP, the automatic train protection system, which will take care of the entire train operation safe. And we are having the ATS, where the complete operations can be taken care. So this is how currently the CBTCs are built upon. So there are wayside quite a few hardware, and also on the onboard we are having things, and there is ATS. There are different proprietary systems of Siemens or any other where actually equipped across the systems. So how it will change? Suppose if we are going towards from the conventional CBTC to the signaling X, so-called the Siemens word, we call it as the distributed smart safe system, which is DS3. So all the wayside elements is being taken to the complete server cabinet kind of a thing, in which all these ATS, the wayside unit, the interlockings, everything will be, the logic, the standard logic will be taken to the COTS-based platform, the commercially off-the-shelf, and then it will take care of the entire operations of the system. So what does it give the benefits? So the signaling X, these are all the benefits that we can see currently. So up to 20% of the operational efficiency we are going to get by reducing the hardware, because the Siemens proprietary hardware is getting moved, the logics, everything is moved to the COTS-based platform. So that's where the hardware is getting reduced and it's getting harmonized. We need not to have Siemens own servers. We can get the market servers which are on the COTS-based platform, HP, Dell, IBM, these kind of servers. And from the maintenance perspective also, it would be a lot easy. And besides this, we are having a 15% of the CapEx savings, because a lot of space that we are going to install these server cabinets is going to reduce in a small server cabinet. And these server cabinets will occupy less than 20% of the space currently. And the outdoor equipments which are there right now at the station interlocking locations, the ACR rooms, all these equipment also will be optimized. The cabling, a lot of copper cable currently we are having. This is also further getting optimized completely, and all the things, the communication will be moving to the OFC based. So the geo-redundancy, this is something which is our key function or the key performance, I would say. So when these servers, when we are saying these servers will operate on a 2 out of 3 architecture, and these 3 servers, we can keep it in 3 different locations. For example, out of these 3 servers, if one server is down, still the remaining 2 servers can ensure the utmost safety and the availability of the system. There will not be any interruptions to the train operations. And once this 3rd server, which is in a different location, is up, with the feature that we are having, it's called self-healing. It will take care of the entire operations of the 3rd server also. It will get clowned by the first 2 servers which are running. And after a certain quarantine period, the 3rd server which is up, it's absolutely healthy. It will get voted by the 2 servers. And once after a certain number of operations, we can fix this third server also, and it will come up to the same level of the first two servers, and it will come back to the online, all the three servers. So in this way, we are ensuring the hot geo redundancy. The security approaches, so we are having the Core Shield platform, which is the highest level of security that we are establishing within the system. And the beauty of this is the patches. We need not to go to the respective locations to update the modifications or the software updates. We can do this remotely. So this is the beauty that we are having with respect to the uptime of almost 24/7 with 100% uptime. So if I just go a bit insights, is it just the theory or is it proven somewhere? So this is something we already proven. I mean, we demonstrated live in Singapore on the test track. I mean, in which the test track of 2-3 kilometers is equipped with both the technologies. Maybe I can just show you a similar example here, in which the conventional CBTC is also working, and the DS3 platform is also working, in which it will get with a simple switchover, both the functions are absolutely working, and it's completely demonstrated. If I just scale it down to a rough project of 20 kilometers in the country, in which we are having 4 interlockings, 20 stations, a couple of depots, 1 operation control center, and 1 backup control center. So these many cabinets will be having roughly, when we do a math, roughly 40 plus cabinets will come. So these 40 plus cabinets will get reduced. If we operate with a DS3, it's going to be reduced close to 6. The servers will be reduced to 6 numbers of the cabinets. So the space, we can see how much it will be reduced. And currently, what we are seeing on the screen, everything is stored at the OCC, all the 3 servers. We can further make it in such a way that we can keep it in 1 server in the OCC, 1 server is in the depot, and 1 server is somewhere in the BCC or somewhere like this. And suppose if the BCC server is off, the remaining 2 servers which are there, 1 in the OCC and 1 in the depot, will take care of the entire operations seamlessly. So if I just do this same, this is the Singapore architecture which we have done, in which we are having the conventional style, where we are having the interlocking, the diagnostics, the TTS, the train-to-track communication system, and the automatic train protection system, with the object controllers where the interlocking and the control elements which are connected to the field will be there, and the control center will be there. So by introducing the COTS-based system, in addition to this current conventional system, which is based on the Core Shield platform, and the safety platform is based on the DS3, the distributed smart safe system, all these 4 will be moved to the COTS-based platform. With this way, with the help of a simple switchover, we can make the conventional CBTC also as well as the DS3 also. So since it is in the trial states in the test track, we demonstrated like this. Otherwise, down the line, once we have the more references in the globe, we are going to switch over the CBTC from our conventional style to the DS3. Maybe if I just talk in summary, so the signaling X is a hot geo-redundancy by its design. As I said, we will be having 3 different places, 3 servers, and if one fails also, the remaining 2 will take care. If any kind of a power issue or if any kind of issue, unless the complete floor is flooded with water or maybe with a fire, something like that, if it's some power failure or something, it will take care of the entire operations. With this self-healing methodology, there will not be any interruption at all to the system. The business logic is going to be untouched. What does that mean? So whatever the logic that we are going to put it on the interlocking, the ATS, the ATP, TTS, is not going to change at all. The same logic, whatever we are loading currently on our proprietary softwares, it will be taken to the COTS-based platform, which is on the DS3, and this will take care of the entire operations of the signaling system. The security approach. So the multi-layer security approach, with the help of the Core Shield, we are going to have utmost security based on the S2L2 Linux platforms. So the most important thing is the obsolescence. Right now, we are having this issue across all major signaling industries, this obsolescence, where the proprietary hardware, some of the capacitors or the components are getting obsolescent. So with the using of this COTS-based platform, we understood from the analysis that every 2-3 years, the speed or the performance of these servers getting doubled, almost. So that means we are going to get more faster and the reliable servers down the line, yeah? The way we are having this Windows is getting updated, the Microsoft is getting updated. In the same way, all the servers also will keep updating itself. The scalability is no more a constraint. There is no limit as such. We can take care of one server, two servers. There is no issue with respect to the scalability. It will take care of the entire operations seamlessly. The last one, the harmonized hardware. All these signaling systems are different. We all know ATP is different. We all know the interlocking is different. We all know ATS is different. But by introducing all these different sets of hardware, bringing into the COTS-based platform in a harmonized way, which will give, from the spare parts perspective, it will be a lot easy. As I mentioned already, the software patches is going to be easy with the help of the remote updations. So we just tried to cover everything in a short video. Maybe I'll just play it.
Control is evolving. Our CBTC system, Train Guard and Team, is entering a new era. Signaling X. Signaling X runs on commercial off-the-shelf standard hardware. While comprehensive cybersecurity is ensured by our core shield infrastructure. Building on that, DS3, which is the world's first hardware-independent safety platform. DS3, Distributed Smart Safe System, our safety platform. DS3 guarantees smooth and risk-free migration of existing systems and applications, including automatic train protection, interlocking, communications-based train control, automatic train supervision, SCADA, diagnostics, and IT security applications, all bundled in Signaling X, one signaling data center. Signaling X makes it possible to run our well-proven CBTC application for one line or for one entire city. A flexible on-premises signaling data center that delivers maximum availability and zero downtime. The Signaling X benefits are reduced lifecycle costs, highest levels of safety and security, and geographical redundancy. Signaling X, when a signaling data center controls an entire network. Smart, safe, and scalable.
So that's it. Thank you so much for the opportunity. Any questions? Yes? Sir.
My name is Rajesh Agarwal. I retired as a member rolling stock of Indian Railways. So it's very good that you have the CBTC, but you know CBTC is a system that is about 15 years old now with the coming of ETCS. So what is it that you're doing to make the CBTC a little more open source? I mean, like things like ATP, things like ATS, and they should all become open source now like ETCS, and you should make your system more interoperable. I mean, you can protect your kernel technologies, you can protect your IP, you can protect your proprietary, but what is it that Siemens is doing to make it more interchangeable like an ETCS system, which is like, now because CBTC, as I said, is more than 15 years old.
So just to, thank you, sir. Thank you for that question. So we already started having these discussions with DMRC also. So how to make these systems interoperable. So just to say that the products that we are using, the ATP product, the interlocking product, the Excel counter product, right now we are working on a platform called ULinks. Yeah, the ULinks is based on the standard interface protocol, we call it in the Indian Railways. So all these products are already working towards this ULinks platform. Down the line, within next 12 to 18 months, max in 2 years, all the systems will be translated to the ULinks-based platform. So from the portfolio perspective, the CBTC is based on the IEC some specification of 144. So it is not actually, you're right, it is not interoperable right now. But having said that, we are open to work with the country. Right now, the discussions are ongoing right now with the DMRC, how to make these systems based on the standard interface protocol, which actually our systems are. The high speed which we are offering is the same system. The ATP, the interlocking axle counter, the ATS rail 9000, absolutely the same systems. Only the need of the customer, based on that, we can make the systems interoperable, and obviously, we have to work together with the entire metro agencies in the country to do this. Thank you.